And the more you need to compensate, the more wealth is concentrated. The more political influence in the form of wealth that you can spend is concentrated. So the way we do that is we look at any number of wealthiest from the top person, 2 or 3, all the way down to n-1 of them, again, individuals or groups. And we ask how many do we need to compensate. So this then gives us an n-1 tuple of numbers, and these numbers tell us how concentrated, for this specific quantile, or not quantile, for this specific number of wealthiest, how concentrated in that respect the distribution is. Well, we define, so consider any distribution y in our domain, again rank order, and consider any number of wealthiest between 1 and n-1. Clearly we don't have, there's no point in considering the n wealthiest because that's the whole society. So we define our basic indicator Q as a function of the distribution under consideration and the number of richest or wealthiest as the minimal number of low income or low wealth people we need to compensate for the aggregate wealth of the wealthiest. So that's the minimal number of individuals from 1 to n, such that if we look at the aggregate wealth of the s lowest wealth people, the sum of the yi from 1 to s, we get at least as much as the aggregate wealth of the t wealthiest. And we can do that for any number. So this gives us an n-1 tuple of values, and these are numbers of people, right? Just how many do I need to compensate or to match, at least match the aggregate spending power of the wealthiest. Just let me illustrate this with a little diagram. We can illustrate this by means of the political concentration curve. Suppose we have individuals, and we have a distribution 2, 2, 2, 2, 4, 8, 9, 8 of them. So this is T, the number of wealthiest we want to consider, that will run from 1 to 7. And we plot against that the number of low wealth people we need to compensate. And that could go from 1, will in general go from 1 to 8. Alright, so if we just look at the wealthiest person with a wealth of 9, we need 5 of the low wealth people to compensate for that. So Q of y and 1 is 5. If we look at the 2 wealthiest, they are in aggregate wealth of 17. But to compensate for that, we need 5, 6, 7. And that's also what we need to compensate for the top 3. Once we have hit that, if we start at 4, we need everybody in the whole society to compensate for that. So a diagrammatic illustration of that is the following. Political influence concentration curve, and it basically looks like that. Notice I picked an example to illustrate that we do not have to have strict monotonicity here. Well, we have to have weak monotonicity by definition. It doesn't have to be strict, and it doesn't have to have anything like decreasing marginal values or anything. That's not too surprising because it's a discrete problem. Right? So if you have flat portions, that's not too surprising. All right, now we ended up with well, we condense the information we have in a distribution into an n-1 tuple of these numbers. The question is, how do we aggregate those? Now there is a preceding paper by Bossert, Ceriani, and Lopez Calva, and they suggest to just add them. We're a little reluctant to do that. I certainly am very reluctant to do that, simply because that implicitly means compensating for the top person has the same weight as compensating for n-1 people. That to me seems not the most intuitive way to proceed, shall we say. One way to avoid this is to be much more reserved, much more conservative in our judgment and say, well, let's just look at the dominance criterion. Say, well, we declare one distribution to be associated with more concentration of political influence if all of these numbers are greater than or equal for one distribution than for another. So if you take any two distributions, y and z, in our set of rank-ordered wealth distributions, we define the quasi-ordering RC, C for concentration, by just looking at dominance, right? The distribution y weakly dominates the distribution z, given only these values, u of y and t, for y, for each possible number of wealthiest, is greater than or equal to the corresponding value for z for each t. Now this is a very, again, conservative approach. We just look at each t at a time, and we say we only make a judgment, we only make a definitive judgment if they all agree. Clearly that seems to be overly cautious, because again, if you look at, if you have a population of 40 million, and all of them by two have a total aggregate, an aggregate income that you need to compensate with a certain number of low wealth people, that doesn't seem to be a very significant number. What you really have to worry about is what happens at the top. The top individual, the top 2, the top 3, etc., top 10 even, or, well, Forbes 400, for example. And so I would say at some point we may want to modify this a little. Another alternative is to look at to think of these units not as individuals or households, but as entire groups. Then it becomes more plausible to go all the way down.
Can you rank wealth distribution with different population? So what if Y and Z are the wealth distributions of the population with a different number of individuals?
That's the problem, and the reason is because these quasi-orderings don't perform very well across population sizes. For a very simple example, none of this will be a replication variable. We don't have anything like recursivity, and I'll come back to that later on, because that's one of the reasons why characterizing anything here is a non-trivial issue.
Yeah, but it looks like that it's like first order stochastic
dominance. Yes. Oh yes.
So
that's what it is.
But in that case you can compare the distribution with different supports. So it's more or less.
You can, but they don't have very appealing properties. It's the interpretation becomes much harder. I mean, you can do it, but it's just not good. Excessively nice.
Do you check second order stochastic order?
Yeah, but again, the properties are iffy, to put it mildly. And I mean, this is something we probably will look into it in more detail at some point, or we may look into it in more detail. What I just mentioned is, well, again, we don't have a characterization at this stage. And while I'm not saying it's not possible to characterize, of course, everything can be characterized, such as the property itself. But if we don't have what we would comfortably consider a non-trivial or non-degenerate characterization. What we do have, though, and what we want to do now and next is we try to link this to something that has appeared in the literature before in a very different context, and that's what the Gini referred to as transvariation. And you probably many of you here who know much more about transvariation than I do. The reason is because I guess at least traditionally, my impression is that in Italy, a lot of emphasis has been put on public economics, right? So in many undergraduate programs, you probably get a lot more public economics than we would get in North America. And Anyway, so transvariation is a concept that's nothing surprising, but in any way, basically, if you have a distribution, and it doesn't have to be wealth, it could be any variable, and you divide the population into groups, or you identify groups. You say, for example, one group, you take a member from two separate groups, and you say the member of this,